answers to lesson 33-2, cylinders and cones. It says describe the shape of the cross sections that are perpendicular to the base of a right cylinder. Well, you know me. I'm not going to just describe it. I'm going to show you. So here we go. Here's a right cylinder. Here is a plane that is perpendicular to the base. And here is another one, and another one, and another one, and another one, and another one. And there's a whole bunch of them. There's infinite many of them. And you see me turning it, and then this is the result of that cross section. I think if I move this down a little bit, and I can change the size of the cylinder. This is the result of the cross section. This is what you're seeing over here. So we see this a rectangle. Figure has one base. Okay, well, in this lesson, we are only dealing with cylinders and cones. It has one base. It's a cone. So I keep reading. It says the distance from the center of the base to the vertex is greater than the height. If it's not the same as the height, then it's not a right cone. So it must be an oblique cone. Emma and Malia are both studying cross sections of right cylinders. Emma states that all planes that pass through the axis of the cylinder, so in other words, we have to cut it in half, form cross sections in the shape of a circle. Well, it's a good thing that I have this over here. Okay, looks like that is not a circle. So, is it going to cut it? Is it going to slice through the axis? Yes, because this axis goes straight down from that green dot. So if it was a string and this were a candle, we would be as we sliced it. And we would get an oval, not a circle. Now, to be a circle, it would need to be parallel to the bases and probably 0. Yeah, parallel to the bases, and that's going to give us a circle. But you put any tilt to it whatsoever, and it becomes an ellipse, which you will study in pre-cal. Okay, the next question, provide a counterexample. We did an ellipse. So make sense of the problem. PVC is a type of plastic that is used in construction. A PVC pipe with 4 inches in diameter is used to transfer a cleaning solution into a process vessel. Explain how to compute the cross-sectional area of the pipe. Well, the pipe is a cylinder, and the cross-section of a cylinder that is parallel to the base we just read is a circle. So how do you find the area of a circle? The area of a circle is pi r squared. And it says that the pipe has a radius of 4. So it'll be area equals 16 pi. All right, we've got a graphic designer working on a new label for a can. The radius of the cylinder is 12. The distance between the top and the bottom of the can is 15. What shape is the label? Well, I know you guys have all peeled a label off a can and laid it flat. It's just going to be a rectangle. We kind of looked at that a while ago when we were looking at nets. So this came wrapped around the can, so we know that this dimension of the rectangle is the same thing as the circumference. It wraps around the can. Circumference is 2 pi r. They tell us right here that the radius is 12. So that means that the circumference is 2 times 12. That's 24 pi. I don't know if y'all can see this flashing on and off or not. It's flashing on and off every time I write. So what are the dimensions of the label? So it's 24 pi, and if we need an approximation of 24 pi, it's 24 pi is about 75.4, what are our units? Centimeters. So it's going to be about 75.4 centimeters. That's going to be the circumference. That's going to be, we'll say, about 75.4 centimeters. What are the dimensions label? Explain how do you determine. I did that. What's the area? So 75.4 times 15, that to the nearest square centimeter. So I got 1,130.97. So I'm going to round that to 1,131. 1,131 centimeters squared. Okay, now I spent probably an hour looking for examples for these last two. Couldn't find one. So all I'm going to do is tell you what the Springboard book says the answer is and tell you that I don't see it. So it says for each one of these, give the number of axes of symmetry and the number of planes of symmetry. Okay, well, we've seen this one. Over here, when I jumped over here and I said, okay, let's get that perpendicular, and as you turn it, you're creating a new cross section. So, you know, there's infinite number of degrees around. Well, there's 360 degrees, but I can cut that into infinite many pieces. There's infinite many diagonals that you can draw because you can always draw it between 2 points. And I can find between. You give me 2 other points that are even closer together and I can still find between. I know there's a difference between theoretical and actually finding a pencil small enough to go between 2 points. It's 2 different stories, but this has infinite many planes that will cut that into two equal pieces. And the same thing is true about this right cone, because we've got this axis of symmetry that's going right down through the middle, and then I could draw an axis there and there and there and there and there and there. Just keep going all the way around the cone. These two, the answer key says that this oblique cylinder does not have an axis of symmetry, which I agree with. Because there's no line that you can draw that will divide this into 2 different pieces, or you'll be able to rotate around and create itself. But it says that it has one plane of symmetry. I don't know where that plane of symmetry would be. I just don't. Unless it's a plane that goes right down through the middle, like this. Because planes don't have to be vertical or horizontal. But I would still argue that when I get through, that the angle that's formed right here is not the same as the angle that's formed right here. So I don't see it. It says the same thing for both answers. No axis of symmetry and one plane of symmetry. So I'll let y'all wrestle with that. I couldn't see it. But anyway, that's the end of this lesson. So I will see you in the next one.